All right, guys, welcome back. In this lesson, we are going to talk about electric fields. Just in a basic introduction, like what's an electric field, what's the formula for electric field strength, and how is this different than the electrostatic force, which is often confused. Okay, first and foremost, what is an electric field? Well, first I want to let's go back a little bit and compare to the gravitational force. So if I look at the force due to gravity, remember, if I have Earth, there was a region around the Earth in which if you put a mass in here, it would get pulled towards the center of the Earth. And this was because that mass was located in this invisible field out here that we called the gravitational field. So there's a force due to gravity, and then there's a gravitational field. But they are two very different things. Well, this we can now relate to a charge. If I happen to have some charge around this area of charge, there's going to be this region in here that if I put another charge inside of here, it will be affected and pulled by this electric field. All right, and as you get further away, we'll see that that electric field strength will go down. So what the electric field is just an area, an invisible region around a charge that attracts or repels other charges. Now the formula for this is just given as capital E, the electric field strength, is equal to Fe over some Q. And where E is equal to electric field strength, and that's going to be given in newtons per coulomb for the unit. As we can see, newtons per coulomb. All right. Fe is going to be the electrostatic force. And Q is some charge in the field, in the electric field. Okay. So the confusion sometimes comes in is the difference between Fe and E. All right, and this is kind of like a cause and effect. When I just have some sort of charge here, so the region that's around this charge is always going to be there regardless of what else is going on. So this region, this electric field, is always there. So right now, with no other charges, there's no electric field. There's no electric force. There's no Fe, right? Because we know for an Fe to happen, we need Q1 and Q2, right? But then once I throw another charge in here, right? Once I put another charge into here, these two charges are going to repel one another. So now I'm going to see some sort of Fe. All right, and the Fe is caused by the electric field. All right, so they are very, very different, guys. You have to make sure that you do not confuse the difference between these two. In here is the entire electric field, and then when you put something inside that electric field, then you get an electrostatic force. All right, so that's just a basic introduction. We'll go through on the next video how to solve for electric field strength and how to use that formula, as well as looking at what directions the electric fields point around certain charges.